Solve tan theta plus pi by 6 is equal to tan pi minus theta, for theta being between 0 and pi. Now, before we look at this one, let's try to look at sort of the general solution for tan theta is equal to tan alpha. So this would be considered, all of this will be considered theta, and this would be considered to be alpha. And let's consider a specific case where we do tan theta is equal to tan pi by 6. It's the same sort of format. Initially, just between minus pi and pi, and then we can expand that to see how the solutions are formed. So tan theta is equal to 1 over root 3, because tan of pi by 6 is that. This is positive. So if we do our South Asian tennis club or cast, and we normally make the angles in the against the x-axis, and we need to consider the first and the third quadrant, because that's where tangent is positive, so making an angle of pi by 6 there, an angle of pi by 6 there. Then we can get solutions. If we're solving from minus pi to pi, the first solution will be pi minus pi plus pi by 6, the two solutions. And the second solution will be 0 plus pi by 6, which is pi by 6. Minus pi plus pi by 6 gives me minus 5 pi by 6, and then we get pi by 6 from that one. So writing that all out again. Now further solutions can be obtained from each of these by adding 2 pi, because this one, if we keep going around the circle, it's going to repeat itself after 2 pi. Same here, and then the same for this one here. And also going back the other way as well, going anti-clockwise, clockwise and anti-clockwise, sorry. So, starting with minus 5 pi by 6, okay, if we go forward by 2 pi, that's going to give me 7 pi by 6, and then adding another 2 pi will give me 19 pi by 6. Going backwards will give me minus 17 pi by 6, minus 29 pi by 6, and that, so on. So they're all going to be multiples of pi. And then for this one here, pi by 6, if I add 2 pi, I get 13 pi by 6, 25 pi by 6, and then going back the other way, minus 11 pi by 6, minus 23 pi by 6. Combining these, so let's combine them, starting with the lowest one here, so we've got minus 29 by 6, minus 23 pi by 6, minus 17 pi by 6, minus 11 pi by 6, minus 5 pi by 6, pi by 6, 7 pi by 6, 13 pi by 6, 19 pi by 6, and 25 pi by 6. So to notice that these will carry on that way and that way as well. So we can come up with a way of writing them all down, and we will notice that we go from one to the other by adding pi each time. And that makes sense because pi repeats itself after pi radians. So sorry, tan theta repeats itself after pi radians. Now for tan theta equal to tan pi by 6, we're going to get that theta is going to be some multiple of pi plus pi by 6. So this will be the base angle, the first angle we get here. So when n is 0, obviously we get that solution pi by 6. N has to be an integer, positive or negative. When n is 1, we're going to get pi plus pi by 6, which is going to give me 7 pi by 6. When n is 2, we're going to get 2 pi plus pi by 6 and 13 pi by 6, etc. When n is minus 1, we're going to get pi minus pi plus pi by 6, which gives me that one. When n is minus 2, we're going to get that one, and etc. So this formula here will generate all these solutions. So this is called the general solution for this particular equation. So if we take it just to tan theta is equal to tan alpha, then theta will be n pi plus whatever alpha is for n belonging to integers. This is called the general solution for this particular equation. So for our original equation, we had that tan theta plus pi by 6 is equal to tan pi minus theta. So we've got here tan theta is equal to tan alpha. So what we're going to do is say theta is equal to theta plus pi by 6, and then the alpha is equal to pi minus theta. And we were solving this between 0 and pi. So we're going to have that theta, using this here, theta plus pi by 6 will be equal to n pi plus my alpha, which is pi by pi minus theta. Rearranging that a little bit, so we're going to get that n has to be an integer, of course. We're going to get 2 theta if we add 2 theta to both sides, and then if we take pi by 6, we're going to end up with that 2 theta is equal to n pi plus 5 pi by 6. So when n is equal to 0, which is the first solution, we're going to get that 2 theta is 5 pi by 6. That's going to be 0, and therefore theta will be 5 pi by 12. So that's going to be one solution. And now the second solution we can check, as long as the angle must fall between 0 and pi. So when n is equal to 1, we're going to get that 2 theta is going to be 1 pi plus 5 pi by 6, which is 2 theta is 11 pi by 6. And then dividing by 2, we're going to get that theta is 11 pi by 12. Therefore, hence, there are two solutions, because 11 pi by 12 is less than pi. Hence, the solutions are 5 pi by 12, or theta is 11 pi by 12. Now, if we try other values of n, and we could do this, but for all other values of n, the angles will fall out of this range, and therefore they are not solutions. Okay, so this has been a video to show you how to solve equations of the type tan theta is equal to tan alpha by using what's known as the general solution. I hope you've understood, and I thank you very much for watching.